So now in the last two parts of rational expressions, exactly as we did with fractions, we will talk about multiplying and dividing rational expressions and adding and subtracting them. So multiply and divide is very, very straightforward. But again, you still have to keep in mind that we have to find the restrictions for these rational expressions for all of the reasons that I've discussed in the previous video. Right, we will now build on the ideas that we've already discussed. In order to multiply or divide rational expressions, we must first simplify each expression using the same approach we did previously. How do we simplify them? Factorize the numerator, factorize the denominator, find which factors are common and cancel, and then multiply numerator to numerator and denominator to denominator. Here we will utilize the rules we discussed under the sections, products and factorization. When dividing rational expressions, we will follow the same rules as we did for fractions. That's when you have a numerator and denominator. So when you have an integer over an integer. However, we must remember to multiply the first rational expression by the reciprocal of the second. Remember to state any restrictions if applicable for the reasons we have already discussed previously. So, there's many ways that you could do it. You could first multiply the numerator by numerator and denominator by denominator, or you could simplify each expression first and then multiply, which will be a better approach because you work with less terms as you go down the line. Okay, here again, first set the denominator to 0, so you have two rational expressions here. X minus 1 cannot be equal to 0, or x plus 2 cannot be equal to 0, so therefore x cannot equal to 1 or x cannot equal to minus 2. And and then basically here we can simplify because that's a factor that is common to both the denominator and the numerator. Okay, let's look at the next question here. That's why I said see now with more complicated questions, simplify each rational expression and then simplify and then work down. So basically here, if I factorize this, I'll get x plus 6, x minus 1. Factorize the denominator, I get x minus 1, x plus 2. The x minus 1 cancels. And if I look at this one here, I can't really simplify this rational expression, right? We can only factorize the denominator. Then I have to set 1, 2, and 3 of these terms to 0 to find out which values of x will the denominators be 0. And we find that to be 1, minus 2, and minus 6. And at these points, the entire expression will be 0. So therefore, at these points here, the entire denominator will be 0, so it will render this entire expression undefined. So therefore, x cannot equal to 1, minus 2, and minus 6. And if we cancel this and this, we can cancel that and that. So we're left with x minus 1 and x plus 2 all squared. Right? Very simple. Right, in this last question, slightly more complicated because we're dealing with division here. But we apply the same rules. Factorize the numerator, factorize the denominator. Factorize the numerator, factorize the denominator. In the first part, we get x plus 6, x minus 1. In the denominator, we get x minus 1, x plus 2. Here, we get x plus 2 and x plus 6, right? I skipped a step here. So all I did was I factorized, and then I took the first fraction and multiplied by the reciprocal of the second. So that's why we got this here and here. Right, then we can start cancelling. So this x minus 1 will cancel. Right? This x plus 6 and x plus 6 will cancel. This x plus 2 and x plus 2 and multiply together will give you x plus 2 squared, which will cancel with this x plus 2 squared. So we're left with x minus 1. And to get our restrictions, the way your mind needs to start working now is by saying that whenever you're trying to do anything to a question, always come back to the original question. So you're trying to make a decision. Which denominators am I going to set to 0? Do I set these denominators to 0 or do I set these denominators to 0? The answer is you set these denominators to 0. The one from the question. Not the re-expressed form. It's the one from the question. The question is what we are trying to solve, not the re-expressed form. Here we're re-expressing. Right? So if you do that, you'll get x minus 1, x plus 2. This will solve to x minus 1, x plus 2, which are the only denominators that we have to focus on. So we'll get x cannot equal to 1 and x cannot equal to minus 2. Understood? Because if you came here, let's say you came and you took these values. Because if you took these values, these denominators and set it to 0, then at minus 6, you would have added another restriction here that x cannot equal to minus 6, but it does exist at minus 6. See, this is just a re-expression of that. But what's more superior is the question itself. So that's why you have to always go back to this. Now, if you were given the question like this, if you started off with this, then yeah, for sure, you'll have 1, 2, 3 restrictions. But since you're given the question, work with what is given. work with what is given. That's what you need to remember. Okay, but it's a very simple question.